how can we use statistics to help us predict or at least make some guesses, educated guesses, on what's going to happen in the future, particularly the stock market or some other financial market that we may be interested in. So this is maybe more geared towards those of you who are finance majors, but there are a lot of ideas that others can benefit from. So picking it up here on page 182, the title is called Tool for Time Series, Linear Combinations, etc. So we're going to be exploring some of the ideas of time series for us to help predict and sort of analyze past data to maybe predict what's for the future data. So one of those things we need to know is the mean and the standard deviation of these sort of time series expressions. So let's first start off with an example of just terms of expected return. So let's suppose that I'm going to invest my money in bonds, stocks, and real estate, and I'm expecting a 3% return on bonds, 10% expected return on stocks, and 2% expected return on real estate. And let's suppose that I'm going to put 20% of my portfolio is going to be in bonds, 70% in stocks, and 10% in real estate. So in other words, what I have here is 20% are going to be in bonds, 70% is going to be in stocks, and 10% is going to be in real estate. And so what I want to do is find out what's my expected return of my portfolio. Well, what that's going to be is 0.2 times an expected value of bonds, 0.7 expected value of stocks, plus 0.1 expected value of my real estate. So this is going to be 0.2 times 0.03, because that's my mean return. In some sense, this is just the mean of this. 0.7 times 0.10 plus 10 times 0.02. And if I add those all up, I get 0.006, 0.07, 0.002, and all told I get 0.78, or a 7.8% return. Not too shabby. The question is, well, why not just put it all in stocks? And that's where we're going to have to talk a little bit about volatility and variation. So this just kind of gives us an example of just starting off how we might do this. So let's go back to our course pack and let's do another example of where we have some investments. So this is back for Dr. Constantine, who wrote these notes. His retirement account has this following portfolio. Okay, so his portfolio is in 40% is in social choice, 35% is in stock, 15% is in this one called global, and 10% is in real estate funds. And so just so I have this a little bit easier, I'm going to write this as X1, X2, X3, and X4. All right. And what we may want to do then is look at its portfolio as 0.4 times X1, 0.35 times X2, plus 0.15 X3, plus 0.10 X4. So this is, again, his portfolio. Notice that this all adds up to 100 because we're looking at 100%. It doesn't necessarily always have to be, but and we're going to compute a weighted average for this value. Another type one that we have would be from our prior course where we had to take the sample means. And the sample means was just x bar is 1 over n x1 plus 1 over n x2 dot 1 over xn. So this is linear combination of the x's, and each of the weights are 1 over n. So in some sense, you're weighting the mean. And what you found out, what's my expected value of x bar, huh? Well, that's going to be 1 over n, the expected value of x1, plus 1 over n, the expected value of x2, all the way out to 1 over n, the expected value of xn. Well, expected value of x1 was going to be mu, and x2 was going to be mu, and 1 over n is going to be mu. So I have n 1 over n mu's, which gave me mu, which is why when I take all my sampling distribution of samples means I'm still going to get the population mean. And finally, maybe this is where we're getting into the time series. Suppose we want to take a look at the Standard & Poor's 500 index, and let's say x1, x2 is the value of the Standard & Poor's index at the end of successive days. So maybe I want to what's called smooth out the daily fluctuations, maybe to see the trends more clearly. And so it's going to be the average of the 3 previous days. So then on the third day it'd be the average of the x2, x3, x4, and then at y4 would be average of x3, x4, 5. So the roles of coefficients, again, are a1, a2, a3, and all the other ai's are 0. And the coefficients play into that. So here we have 4 goals. We want to know the shape, the center, and eventually we'll want to know the spread and then the relationship. So we'll pick that up in our next lesson.